Alrighty, good afternoon, everyone. Thank you all for joining. We'd like to present our research on enhancing object detection and avoidance for robots in challenging environments using artificial intelligence. My name is Ayan Khan. I'm a product manager at Amrita Inc. And today I'm joined by Matthew Nguyen, who is a student at North Stafford High School. And I'd like to hand it over to Matthew, who's going to start off with the addressing problem.
Robotic systems are increasingly being deployed in a variety of environments, including fog, rain, snow, and low light. These environments pose significant challenges to current object detection and avoidance systems. Standard sensors such as cameras, LiDAR, and ultrasonic sensors are often experience degraded performance in these conditions, which lead to a risk of accidents and collisions during navigation.
All right, so I'm going to go over some of the solutions. So here are a couple of solutions within the automotive and the robotics industry. So we have Mobileye that has developed various solutions that can be integrated with autonomous vehicles. Their solutions are capable of lane departure warning systems in adverse weather conditions, as well as obtaining real-time speed information and adjusting the speed accordingly, as well as staying alert on road conditions and alerting users on whether there are potholes or bumps in the road. Intel has developed Intel RealSense, which is another device that can allow robots to essentially interact and perceive with their environment. There are also different models that are associated with Intel RealSense, and they can be used for various different applications. However, they all serve the same purpose of being able to enhance robotic autonomy. So I'd like to share with you an example of a deep learning model. This is called MaskR-CNN. And what this is it is essentially a model that can perform instant segmentation, which can be achieved due to the addition of an extra mask head, as shown right over there. And this improves this improves the accuracy and the detail of each picture. And a very popular application of this specific deep learning model is in UAVs, or unmanned aerial vehicles, where it is used to detect objects from large distances with minute details, and it has the same under various challenging conditions. So like under dust or haze or snow or any object or any challenge that could essentially perceive or hinder the picture. So I'd like to share a few improvements that AI and ML has made based on computer vision. Within the augmented and virtual reality space, it has really immersed the experience by transforming the user's experience to interact with their digital and virtual environments. AI/ML is also enhanced object detection as well as 3D reconstruction through different products, which reduces the computational complexity and enhances the shape of the human pose, respectively. So, for example, the multiply could be used in facial recognition software. So I'd like to share this framework with you. So this is essentially a flowchart that kind of shows the different stages that go through when embedding AI and computer vision into robotics. So you would collect your data and you would process your data, right? And then you take your process data and you would feed it into an ML model. And with that ML model, you'd be able to kind of train the model based on the data that you share. And using the trained model, you can use various other deep learning models depending upon the use case. And then once the model is trained, you'd be able to deploy it as a software into a robot. And that's where you begin the testing of fine-tuning the robot on whether or not it needs to be modified, whether the model needs to be modified by processing the data or making changes to the data as necessary. And that's where the learning and adaptation comes into play. All right, so I'm going to hand it over to Matthew, who's going to talk a little bit about the use case that we used using our software.
So our objective is to process collected terrain information and determine a suitable motor response, whether it's to stop or to go. And the method we used is binary classification. And on this chart, you can see all these variables. There's two types of variables, numerical and categorical. So our categorical variables are drive type, terrain type, obstacle type, and outcome, while our numerical variables are ground clearance, robot velocity, robot weight, obstacle distance, obstacle height, and obstacle width. So this is information we've collected from Enruta Academy's machine learning model. So for accuracy, it says we got a score of 0.7742, which is reasonably good. However, it could be improved by performing various iterations. And on the confusion matrix, it shows that we got there's 31 predictions and 24 of those were accurate, however 7 were not. And here are all how important each variable is to finding the solution. So our top variables are robot velocity, obstacle height, obstacle width, obstacle distance, and terrain type.
Yes. So just to clarify, the ML explainer chart over here kind of shows the most important variables that were crucial in determining whether the motor should stop or should go. The most important being the robot velocity, as determined by the software. All right, finally, I'd like to talk about some benefits of container deployment as well as end-to-end deployment. Starting off with container deployment. Containers encapsulate the software by making it easy to deploy across various different environments, right, without compatibility issues, which is a huge benefit. In addition, containers also allow for efficient scaling of AI applications, which means that you could easily replicate and distribute containers across multiple different platforms. Finally, containers also provide isolated environments, thereby enhancing security as well as any potential vulnerabilities that may exist within the container. And then moving on to end-to-end deployment. End-to-end deployment ensures that all stages of the AI software lifecycle, from the development to production, run smoothly, thereby minimizing the changes of integration issues. In addition, you can also significantly reduce the time to market to bring AI-enhanced robotics, for example, by completely automating the end-to-end process. And finally, with automated end-to-end deployment, that ensures that each release goes through the same rigorous process, thereby maintaining consistent quality. And finally, I just wanted to kind of talk a little bit about opportunities to commercialize. So Matthew and I, we released the opportunities to commercialize our research. There are a couple of avenues that we are looking to explore. Firstly, we would like to explore some partnership opportunities in STEM programs within school districts, which provide a lot of would provide a lot of benefits to students and raise awareness with amongst the high school population on the importance of AI and that it is the future. And we do this through essentially implementing them in student-driven projects. And in addition, we'd also like to seek government support and funding for large-scale deployment for software and services. And with that, that would ease ease achieving end-to-end deployment, which could be readily more achieved, as well as future opportunities for R&D as well. So that concludes our presentation. Thank you all for listening. I'd like to open it up to questions.
So were you guys able to, did you guys get the data from a data set, or was it from a robot that you guys used? Or
So the data was synthetically generated. which was basically nothing. We just came up with the data.
But you guys had experience. I mean, you guys actually do the robotics at school, so you know the domain.
Yes,
very
yes.
well.
I mean, yeah.
So it's a meaningful data set, even though it's synthetic data set. My follow-up question would be, are you using AI models to program your robots today, or is that in your plan, or is that something novel?
Yeah, it's a good question. So as of now, we're not using any AI software, any AI assistance whatsoever.
Yeah.
However, as I mentioned in the last slide, there is definitely a lot of opportunity to implement AI into projects such as the ones that we're doing right now. So Matthew and I are part of Kilroy Robotics, which is a robotics group at Port Stafford High School. And so I'm essentially the coach of the robotics group. And, I have been speaking with other mentors on implementing AI software to better enhance or to make the robot more efficient in performing specific tasks that need to be done in the competitions. So yes, to your question, definitely we do see a lot of opportunity in that.
Nice project, by the way, very, very interesting. So I guess my question is, maybe I didn't catch this, in terms of how you guys modeled this, were you learning actions? Were you learning, in terms of go or stop based on the objects, or were you learning, this is a particular object here? So in other words, I guess I'm asking, how is this incorporated into the control loop?
Yeah,
robot?
Yeah. So this is just the software side of things.
Yeah.
And then once this gets integrated into the robot itself, it can get integrated towards the control loop, which drives the motors. So if the software determines that the robot needs to stop, it will stop. If it's moving, and if it's stationary, if the robot is stationary and the software determines that the robot needs to go, the robot will move.
So the training tells it, the training and then the prediction tells it should stop, or the robot uses that information to determine that it should stop?
The robot uses the information to tell it that it should stop. Yeah, because everything is being fed into the robot. Like the ground clearance, the velocity of the robot at that point in time.
This is basically an AI-driven way to do the object recognition. Yeah.
And I think that the idea is that, can AI be beneficial in foggy conditions, in limited visibility conditions? So that's another aspect of it.
Perfect. Yes, sir.
It's a fantastic project too, and you've learned an awful lot. There's a really neat spin-out company from MIT, Liquid AI, and the motivation for the company is that robots in these type of circumstances, challenging environments, aren't going to have access to telecom in the cloud, and so the model has to be with the robot, and because of that, they have to be much smaller models than like a ChatGPT. And so it's this problem set is driving the decreasing size of the models. So it's really neat.
Yeah, absolutely. Completely agree. That's exactly one application of this. All right. Thank you all.